we'd look at a few weather maps. So that looks like a complicated weather map, and it's called mixed analysis because they draw in fronts, which is cool, and mixed because the green stuff, of course, that green stuff is from radar images or radar information. Basically, it's precipitation, right? The green is precipitation. We're going to talk more about that, but basically, you send out and you look for precipitation. You send out radar is looking for an echo. And the other thing is you see the white wispy stuff. That's from like satellites that are orbiting the Earth. So it's a mixed analysis. And then that is in telecast. I like in telecast. Like I said, I think it gets kind of confusing. I double checked. I wasn't quite sure. I thought I knew. But do you guys see those? I'll pick purple. Do you guys see those lines, kind of I'll circle them, those lines right there? Okay, they're kind of like brown lines. They're hard to see. But those actually are troughs. They mark troughs. And so speaking of troughs then, we'll take a look at the jet stream. And I was kind of playing around with who has a good jet stream. First off, let's see, where was the other jet stream? Well, that's not my jet stream. Maybe I closed it out. But AccuWeather, check this out. Here's their jet stream. This one right up here. I was looking for something complicated, but that simply is their jet stream. You know, and we've been talking about, that would be the polar jet stream. So definitely meandering instead of zonal. And that's actually why we kind of alternate. We're getting warm and then cold and then warm and then cold. Okay, because you figure this is actually bringing us down cold air and this is bringing us up warm air. And I bet if you look, there's another Rossby wave on the other side. Okay, so that's actually kind of what we have going on here. What else? Maybe that was mostly what I wanted to kind of show you. But, so, like, do you guys look online? Do you have a favorite, like, website that you go to get the weather?
I've just been using that new Weather Underground app.
The Weather Underground app?
It's actually really nice.
AccuWeather? John, do you have a favorite one?
Underground.
Underground too?
Yeah. If I'm on the internet on a PC, I go to NOAA, but.
Oh yeah, that's good too, I think. That one's kind of gets in depth too.
My stepdad's a firefighter, so that's what he uses.
Ah.
So it's what I'm used to.
Yeah. So, okay. So, picking up where we left off, in its mature state, thunderstorm has a downdraft now too, updraft and a downdraft. And that downdraft, we said, makes a gust front, okay, in front of, I mean, I love sitting on your porch and a storm's coming, and now we talk about inflow and then a gust front. Actually, they go in opposite directions, but the downdraft can also create these things, and they're usually right underneath the storm, called a downburst. And sometimes, like after a storm, there'll be a lot of talk about the damage the storm did, and they will wonder whether, for instance, those strong winds were from what we call a downburst, or whether they were from a tornado. So a downburst, basically, there won't be any of this. It'll just be a, okay, trees will be flattened. Tornado will, of course, have some rotation to it. But these downbursts, I mean, they're like the same strength as the winds of a tornado, in a sense. So there's downbursts and microbursts, and they're both caused by the downdraft, okay, of a thunderstorm. All right. So, like I was saying, after the fact, if trees are down, they look to see if the pattern of the trees are twisted or not, and if they're just kind of straight. Actually, that was from what we call straight line winds instead of winds that have rotation. I guess Ronald Reagan was flying in Air Force One, and his plane went through one of these microbursts. Okay, so he was okay, but they can kind of be very unexpected, and the problem is correcting for them if you're flying a plane. So this is kind of a series of pictures kind of showing you, it looks like a dust devil, kind of debris being thrown up, but that's because of the impact of either a microburst or a downburst. All right, so we kind of, it's in segments, so kind of 3 segments in this chapter. That was on thunderstorms. Now we're going to talk about lightning for just a little bit, and then we finish up with tornadoes. Okay. Cloud types, and I got another video. Well, first off, before I show you the video, all right, see the 80-20, okay? So lightning, you probably figure lightning has something to do with electricity. So basically, it is electricity. Electricity flowing from one point to another. And basically what electricity is basically electrons going like that. And I go like this because most, 80% of lightning is basically from one cloud to another cloud, okay? Or within the same cloud, okay? And if you've ever heard of sheet lightning, okay, sheet lightning is basically where the whole cloud glows, okay? Sheet lightning is basically electricity running within the cloud, lightning within the cloud. So 80% is that. 20% is the kind I'm going to show you on this video. So 20% is the kind that'll get you. So,
See, you're making me less and less scared to run in the rain.
So don't try that at home. So, I know that little video we watched with the meteorologist kind of talked about safety, but this is a website, and I'll probably try to remember to post it on the Twitter feed, but I just thought it was good. It's by NOAA, and it's due to deal just with lightning. So, for instance, analysis of lightning fatalities. I mentioned it's not golfers, right? You always think, well, duh, come in, right, from the rain. But notice that they went out and they gathered the data, and it says that 2/3 of the deaths are from people who are outside doing something they love, enjoying something leisurely, right? This is deaths by lightning strikes. And during this 9-year period, fishermen accounted for more than 3 times as many as golfers, okay? And then camping and boating was not good either, okay? So don't become a statistic.
Okay, fishing makes sense because they're holding the rod up, right?
Yeah.
For an extended period of time. Whereas golf, you're basically just in your backswing where you have the metal up.
I don't know. Notice this though. Males accounted for 81%.
We're taller.
What's
We're
that?
taller.
Right, yeah. But anyway.
And we're dumber, let's be honest.
I didn't say that.
I did. It's
What-
okay.
What's that?
I wasn't gonna say anything, but
And then, I thought, well, that must have been a dead end. Where else did I go?
have you watched that Into the Storm? It's kind of like The Day After Tomorrow.
Were they what?
The Into the Storm.
Oh, no.
That's something kind of like this, and it's like it's really good. It's kind of like
Really?
The Day After Tomorrow, but
Okay.
don't
Into the
have all
Storm.
that.
Is
Yeah.
it like on the Weather Channel or something?
No, it's an actual movie.
Okay.
So
Oh.
it came out like last year.
I'll have to look into it. Is it kind of new or been out there a while?
I think they made a movie before about it, and then like they redid it, but it shows like. The
And
way
now I
it
want to
was
watch
and-
documentaries about lightning and stuff.
Well, yeah.
Netflix, here I come.
I think Into the Storm. I bet it's not on Netflix though yet, is it?
It might be.
That dude's hoodie string is very.
Yeah. Well, come on. He's trying to make a point. Look what sign he's standing by.
He looks real fertile.
When thunder roars, go indoors. So, and then down here, I think they had some, I think it was misconceptions. But anyway, I think I'm gonna click here, the safety indoors. See, this surprised me. This is what they said on the thing we watched, the little video. You know, the whole thing about, stay off the corded phone. Well, stay off the corded phone, right? None of us really use corded phones really anymore, do we? I guess we do a little bit. Don't touch electrical equipment, right? Okay. Avoid plumbing. I mean, this is just being conservative. I'm just saying. Do not line in concrete or protect your pets. Okay, but anyway, those are just some things if you're inside. So, you know, when your kid says, "Mom, I can't take a shower, it's lightning," they're like, right. So, I don't know. Those are from experts. Let's see what you're supposed to do if you're outdoors. That's indoors. Oh yeah, you're good. Indoors. Outdoors. And then we'll go on. Avoid open fields, tops of hills. Stay away from tall, isolated trees. I like number 3. If you're in a group, spread out to avoid the current. Like, because you know, like cows, they say, you know, cows in a huddle, like, can fry all at once, right?
So basically that one scene in the Field of Dreams when he's on his knees crying in the middle of the field is a really, really dangerous thing that he was doing.
Probably. I haven't seen that movie.
You haven't seen Field of Dreams? Oh, Kevin Costner's excellent. Excellent film.
I'll have to see Field of Dreams too. You liked it too?
I haven't seen it. But
Oh, okay.
Excellent film. It's about baseball. You don't care about baseball? You won't like it, but-
So lightning, respect it, right? So lightning is basically a discharge of electrons from point A to point B, and we're going to talk about why do electrons want to do that, right? And as I talk about this, have you ever taken a balloon and kind of rubbed it on your head and your hair stands up? Like my hair stands up anyway, but basically you have transferred electrons. I can't remember which way it went from the balloon, I think, to your hair. And so basically those opposite things want to attract. So you have not enough electrons and extra electrons. So that's kind of what's going on within a cloud to give us our cloud-to-cloud lightning and our cloud-to-ground lightning. So you kind of see the negatives. That means there's extra electrons there. The positives means that they're missing electrons, basically. So you're like, well, how does that do that? And the answer is they're not really entirely sure. Okay, but when they look at ice crystals, as in snow, okay, they tend to be lighter and they can actually then kind of float to the top and they'll have a positive charge. Grapple, I don't know if we talked much about that, but like I think this slide says, grapple is kind of like it's not beautiful ice crystal. It's solid water, but it's kind of it's like sleet kind of, grapple is, but smaller. And so those will actually kind of congregate near the bottom and have a negative charge. And then do you guys see this at the bottom here? I don't know if you can see it very well. See what's happening down there? Okay, the Earth is a great grounder, which means it can actually go either direction, be a source for electrons or suck up electrons. So basically what happens under a cloud, and it kind of happens stepwise, if you get this happening at the bottom of your cloud, the Earth will respond. Is that not cool or what? So the textbook I used to use used to show like a couple of people just kind of standing there looking goofy into a camera, and their hair was standing up on end. Here's the deal: if your hair starts to stand up on end and you're near a cumulonimbus cloud, basically you are being induced with a charge. Okay, so run. So that's kind of the beginning of it. So you get that charge separation. Okay, and notice what starts first is the leader. Go figure. Okay. The step leader is basically kind of finding its way. Now this would be the 20%. This is the 20% of lightning that goes between the cloud and the ground. So tentatively there is a channel where electrons can flow. This talks about runaway breakdown. I don't usually test over that. Okay, but it starts out with a leader. The thing is have you ever like looked at lightning and sometimes it looks like it's like different flashes, like looks like there's 3 different things 3 different strokes in the one lightning bolt. And that's actually true. So this is kind of the start of it. It's not very bright, definitely not the brightest. Okay, so you can see here what I was talking about, kind of the stringy part over there, the multiple place where electrons have gone back and forth. So a bolt of lightning is not just a, it's kind of a, all really fast. So here we've got kind of the real probably bolt of lightning. I think this says return stroke. It says even a more powerful flow of electrons from the cloud to the ground is your return stroke. So from the cloud to the ground is your return stroke, powerful. So basically this is kaboom, or I guess that's the thunder. We'll talk more about this. But this is the bright one, okay, but before it was something less. Okay, so you kind of have a little bit this kind of going back. Dart leaders can be associated kind of after the initial return stroke. But eventually what will happen is eventually you see this F1 here. Notice what's different is basically we don't have any kind of charge separation kind of under the cloud. So it kind of just neutralizes and ready to try to kind of build it up again. All right. So thunder is the audible part of lightning. Okay. So what creates thunder is something very hot. Let's say as hot as the surface of the sun, not as hot as the interior of the sun. Okay. Okay. So 5 times hotter than the surface of the sun, in the vicinity of that lightning bolt. Electrons are basically moving very fast, and they're just creating immense heat. So here's the deal: is if this is my lightning bolt, this is my lightning bolt. It's very hot. That air around it, I'll make those little green dots here. That's my little nitrogen. That's my little air around it. Basically, it heats up very quickly, and if you heat up air, it's going to expand. So it heats up, and it's going to expand. That's it moving out. It expands, actually, its relocation is faster than the speed that sound travels. It breaks the sound barrier.
So basically it's a sonic boom.
It is a sonic boom. Yep.
It's interesting because thunder sounds so much different than a sonic boom, say when like a jet flies over. So much different.
I don't know. It could be the elevation.
Maybe.
It is a sonic boom. But here's the deal, and let's go ahead and use that image down there. So the red lines is the sonic boom, right? So this actually is going to be the sound waves that are going to reach us, and we're going to call that thunder. And of course we had the bolt itself over here, okay, and the light reaches us, like you guys know. We see the light first, and then we hear the thunder second. So the light travels faster than the thunder. So I don't know, I go with 5 seconds. That's how I learned it growing up. And I looked on the internet, and I've heard between 5 or 3. So that's to say, like whatever seconds you count, like if you counted 10 seconds, okay, between when you saw the flash and you heard the thunder, you would take 10 divided by 5 and you get 2 miles. Okay? So anywhere from, like I said, 3 to 7, but I'd go kind of with 5. So if it was 15 seconds, it would be 3 miles. Okay, if it was 2 seconds, it would be less than a half a mile, that sort of thing.
And it'd be really, really loud.
Yeah, it would be very, very loud. And in fact, along those lines, I have something coming up. But so heat lightning, this is in your textbook, but heat lightning, and I don't think I knew this growing up, but you see it off in the distance, kind of like It's actually sheet lightning. Heat lightning is sheet lightning that is actually so far away that that sound tries to get to you, but it dissipates before it gets to you. So that's heat lightning. So about 12 miles is how far the sound can travel. So kind of like maybe you were saying, you kind of have these different qualities to your thunder. Okay, you've heard a and that usually means it didn't have time to even kind of bounce off of anything. It's a loud clap. Versus kind of a rolling thunder, those are the ones when they're kind of coming our way or leaving us. They have places to bounce off of. So kind of the sound has a different quality to it. All right, on to tornadoes. So, let's see, you've got that. Yes. So we're definitely not going to get through this chapter. Let's just still do a few of these about tornadoes. Okay, so are we okay with what sort of cloud gives us tornadoes? Storm cloud, cumulonimbus cloud, can maybe give us tornadoes. We said that supercells can spawn tornadoes. They don't have to. Okay, tornadoes actually have a central low pressure. Okay, so then not so surprising, consistent with what we talked about. Okay, I'll put an L there for low. That's what we call a cyclone, cyclonic rotation counterclockwise. So that's all consistent with the last chapter when we talked about cyclones and anticyclones. And this kind of goes to what was said earlier, is that if this is your tornado, that's an ugly looking tornado, if you were to look at the low in the center, you would have a very low low and very tight isobars. But they would be very, very localized. I mean, maybe, half a mile, this thing is what we call the vortex of the tornado, kind of the center of it, okay? But that tight pressure gradient is very localized. So tornadoes, maybe you're like me, you kind of listen to the news, what some statistics about them, but they can vary a lot into how long they last and how wide they are. As far as lasting for a long time, they can only be minutes or they can be hours, but even hours is not very long to get the equipment there to study them. So actually, that's why tornadoes are, science does our best. And maybe you're familiar, you watch those documentaries about those vortex sort of things where they basically send the army thing, the tank. Well, no, they could, but they send a tank out there basically to try to intercept a tornado. The drone thing, that kind of reminds me of cows, of the Twister. Basically, they were trying to suck up the little, to try to get information. Twister?
Yeah.
Better than Tremors.
Yeah.
Oh, yeah. Twister's better than Tremors.
Tremors was awful. That entire series was awful.
Yeah. Okay. So the wind speed, that last remark up there, actually, you guys know we're going to use the Fujita scale, just like the Twisters movie. Actually, the enhanced Fujita scale. And that's all based upon wind speed. So here's some pretty pictures of tornadoes. And actually they're called, and I don't know, I'm not good with my names, but you can kind of see, I think that last one down there is a rope kind of shape. I think the middle one might be wedge. So they kind of have different characteristic shapes. But you figure they have different shapes depending upon if they're kind of leaving or coming or going. So the other thing about tornadoes is the only way that you can they are made visible, kind of the milky white, they're made visible. Two things. One, it could be that they're picking up houses and stuff and actually kind of are debris, could be dirt, dust, but that could be some of the milky white you see. The other thing is you could be seeing some actually clouds, some condensed water vapor. But haven't you seen before, like, tornadoes that are kind of invisible? I mean, it's just moving air, and something needs to make it visible. Do you know what I mean? It's not always visible, which is not very safe. So some extremes about tornadoes. We're going to look at where tornadoes generally are, and worldwide, North America gets hit hard with tornadoes. But the deadliest one was in 1989, not that long ago, in Bangladesh. The deadliest one. In the United States, back in 1925, actually killed almost 700 people with a single tornado. Single tornado. Now we're going to talk about tornado outbreaks, but that's a single tornado. Like, really? Tornado outbreaks, again, same year. The biggest 24-hour total tornado outbreak, 147 tornadoes in 1974. Dang. In 2011, U.S. had 753 tornadoes in 1 month. The widest one was 2.5 miles in 2004. For that comment, that is 2.5 miles. Makes you want to go Google some of these, but.
And that was only an F4?
Yep. In the F4.
Maybe the size is what made it an F4. Maybe if it was smaller, it could have been an F5. Maybe the size.
Oh, yeah, that
the
could be.
distance
It broadened
that the
out.
wind had to travel, because isn't that Fujita scale based off the wind speed?
Yeah.
So maybe the size of the wind had to travel slowed it down, so that maybe is why it was an F4.
I don't know. It could be. Then the highest wind speed, 302 miles per hour. The highest elevation in California. The longest transport was 223 miles. Picked up a
Personal check. How did it not get destroyed?
No.
And I wonder if it was
Tornadoes are
sonic.
weird. Yeah.
I'm surprised that Joplin's not on there. There's 2004 on there, because they had a bad tornado.
Yeah, I wonder what year was Joplin. I think I have.
2013?
It was a couple of years.
So I wonder if it
2013.
didn't make it to this edition.
Yeah.
And I think I have a link for Joplin, Missouri, to see pictures of the devastation. So yeah, it's hard to gather information about what's going on in the tornado, but they know some things. So tornadoes drop from storm clouds. Okay, some storm clouds. They need to have a lot of instability. The whole wind shear thing, the tilt thing, okay, the tilted cumulonimbus cloud could go ahead and give you the conditions to spawn this mesoscale rotation inside of your thunderstorm cell. Notice it says tropical cyclones. Tropical cyclones are the things that we call hurricanes. So, you know, hurricanes, we don't have to worry about them, right? Really? But one of the things you already know is that if you were looking down at a hurricane, it kind of has the eye, right? That's the eye. Then it has these spiral rain bands, okay? And so actually in the eye, or around the eye, what we call the eye wall, and we'll talk about this in the next chapter, these little circles I'm drawing, those are actually thunderstorm cells. And thunderstorm cells can bring tornadoes. So actually, as I'm drawing them here, and these are the spiral rain bands, okay, they have thunderstorms there too. So what we kind of bemoan are thunderstorms, okay, they basically are rampant within a cyclone or a hurricane. All right. So we're going to see some statistic or kind of a bar graph to show us when tornadoes do their thing. But between 3 and 8 p.m. There are nighttime tornadoes, right? They're very dangerous. And there are earlier tornadoes than 3. So here's a photo from your textbook. Damage in Tennessee. Kentucky. So notice the word outbreak, okay? Let's see. It looks like this was the same outbreak, okay? And 84 tornadoes, and this is some of the damage that outbreak did. Okay, so if you're like me, you've heard of funnel cloud, and the distinction between a tornado and a funnel cloud is basically how far it reaches. So a funnel cloud is a tornado that hasn't reached the ground. Does that make sense? Okay, it's a funnel cloud. So, but it's funny because in my notes then I talk about the funnel portion of the tornado, okay? And this is what I said before, kind of the reason we can see a tornado, we couldn't see it, you can't see wind moving, but you can see stuff in the air that is in the wind, or wind's pushing the air. So the reason you see it is either debris and dust or condensed water. So in the movie Twister, didn't they talk about right mover or something? Basically, a tornado can split into a couple different ways. Okay, but yeah, but most of them will have a central low, so they'll be going counterclockwise.
I know they have like twin tornadoes that come that form.
Twin tornadoes? I don't know if it is, but your textbook talks about multiple vortices. So basically, here's your main tornado, and you can have other stuff dropping down from it. So I wonder if that's it.
There's on water too.
Water
Yeah.
spouts.
Water spouts. Not seen them, not chased them, but. Oh, let's see. This is like, I'm going to talk about a tornado with multiple suction places. So there's the tornado vortex that's in the middle, and then they can have these things that are called suction vortices. And the suction vortices, I don't know, might be different though. I need to Google twin tornadoes. Yeah. But the suction vortices don't last as long as the main tornado vortex. But I'm going to show you a figure here in a minute of a main tornado vortex and multiple little suction vortices, and you'll notice that, if this is what hit you, you're going to see damage in a different way. So in the center would be your main tornado vortice right here. So there's your tornado going up, and these right here are just kind of extra.
So tornadoes within tornadoes, tornadoception.
Right. That's how I see it. And you can almost see that in the destruction sometimes, it looks like. So 2 ingredients that they think are needed for a tornado, that is a strong updraft. And to me, to get a strong updraft, basically, does this make sense to you too? To get a strong updraft, you need lots of instability. To get a strong updraft. And strong upper level wind. And that's kind of back to your tilted cumulonimbus cloud. So you guys okay with TS? TS is short for thunderstorms. That's kind of what they do like at spotter training. So TS stands for thunderstorms. So in 100 thunderstorms, one of them will spawn a tornado in general. Hail is associated with, we talked about this before, but basically that chunk of liquid, I can't remember, I think one of the videos we watched said it takes the updraft and it gets larger as it goes up, and then it falls back down, and it catches another updraft and it falls back down, and it gets bigger all the time. And as far as I can tell, it's like super cooled water is being added onto it. So and actually that can precede your tornado. So this is your mesocyclone being born. So you kind of have some wind shear going on. See the blue, both arrows are saying that their wind is in the same direction, but the top arrow is going faster than the bottom arrow, the bottom line. Okay, so you have stronger wind at upper elevations, so you can basically get kind of the rotation. That rotating what's going to become a mesocyclone gets moved up within the updraft, okay? And then basically, voila, you might recognize that kind of wrapping sort of updraft around in your supercell. Okay, so that's a rotating mesocyclone within a cumulonimbus cloud, and they're showing a tornado down there. Okay.
That's a really cool picture.
That is pretty. I agree. So I went ahead and brought in some more figures for wall clouds. This is what I did for a few of my things. I basically went out and I Googled photos or images, and so I'm going to bring up a search of wall clouds because I couldn't decide which one I liked the most. But like I said, a wall cloud, see that first one's pretty good. A wall cloud is kind of a, well, I think you said it well. Basically, it's a little bit of cloud that lowers from the base. So that's pretty good. Okay. And tornadoes may or may not have wall clouds. And they'll tell you to look for rotation. This one kind of flanges out. But there's this stuff called scud. And scud is just kind of like miscellaneous clouds that are kind of falling from your base. And if there's no rotation, it's probably scud.
That fourth picture looks nasty.
It does.
It doesn't look like it's going to be fun at all.
That's pretty. Pretty crazy. Oops. Well, I think that's a good place to, we'll start on this slide, because this will remind us of a lot of stuff, trust me. So we'll start on this slide next week. So there won't be anything due next week. Okay. Sounds like a plan.